This lecture relates to the second half of Chapter 4, beginning on page 137, the Relational Model 3 Advanced Topics. It's a part of CIS 307 offered through the Iowa Community College Online Consortium. So we're going to begin here and talk about structure changes. Now, in the first half of the lecture, I discussed the alter table command, and very briefly I had a couple of examples where it was easier to use the alter table command, but it's really not until page 137 that the author begins to discuss this concept. I felt like when I read it that the author made it sound like database changes are quick and easy. And reality is that pushing the buttons to actually make the database change happen isn't hard, but the amount of time that you need to devote on the design aspect of it can be very time consuming. For starters, you don't want to be in a situation where you're having to modify your table design and structure, table structure and design constantly. You need to think big picture from the beginning. It's very important that you do map this table design out, that you've gone through and have a good entity relationship diagram, and that you've you've interviewed users, you've figured out what your end result is, your output, and all of that. I always tell people, don't tell me what I'm going to design to put into a database. You, user, tell me what you want to come out, and so I'm going to interview those users. I'm going to talk to them as I figure it out. So I'm going to spend a lot of time designing my database on paper long before I'm going to begin to design it in any type of database management system. And what's important is that I'm thinking big picture from the beginning, because I want to minimize those time-consuming database changes later on. When something happens and I do have to make changes, again, I need to think big picture as to what type of impact it's going to have on the other tables in my database, on the views, the reports, and ultimately the user interface. Now, I'm going to give you a quick example here. I work here during the day at Eastern Iowa Community Colleges, and I work with our student registration database. It keeps track of a lot of information on, I think last time we checked there were about 200 plus thousand students in it. So there's a lot of data on a lot of people. At our college, you have the ability, the student registration system that we use has the ability to store multiple majors for one student. However, it is our own policy that a student can only have one primary major, and any other major that they have is stored in that database system as secondary major. Now, because this is not a database that we wrote, it's a database that we purchased, and it's huge. Our database has thousands of tables in it. We have, some control, some things we have control over, some things we do not. Some modifications that we make, an update to the system will reverse that modification. So some things are handled simply through policy. So as a result, we have a variety of audit reports that are run to capture people who erroneously give a student two primary majors and run them as a secondary major. I have a report that I am required to send to the state of Iowa that identifies students and their majors. Now, I realized that there was a possibility of a student having multiple majors, and by state of Iowa that cannot happen. So in MySQL, I accommodate for this by looking at those situations where a student has more than one major, and I look at the types of majors. For example, if you were going after an information technology AAS, and you also were going after a network certificate, I rank it. The AAS is a higher rank than this network certificate, so therefore the one major I would report to the state would be the AAS. If you were going after an information technology AAS and a business management AAS, both having the same ranking and degree, I then look at the date that you declared the major. And again, if it's a tie, then I think it basically becomes random. I don't know, remember if it's the first one alphabetically or what it is, if you truly manage to declare two majors at the same rank on the same date. I have Another situation, though, where in some other views that one of our programmers designed, the logic was relying on the end user, to run their audits reports daily and to make these corrections to the database. We found an error. We had some people who weren't running their audit reports daily. It was over 70 reports that were impacted because the other programmer didn't think big picture. The other programmer relied on the employees across the district remembering to run their daily audit reports. And if they were even out sick for a week and they didn't run that daily audit report, then the results on their report, the view that used the other programmer's logic, was affected. Over 70 reports were affected. That's somebody not thinking big picture. I looked at it as, yes, I want my users to run the daily audit reports, but I thought bigger. But I know they're not going to every day, so I still programmatically through MySQL wanted to account for that manual procedure falling apart, and I wrote a ranking system. Now, this is just something that happened recently, and it took us a long time to figure out why we had these conflicting answers in these different reports. I have to tell you, it was joyous to discover that mine was right. But the point is somebody didn't think big picture enough. And you really do have to follow a process from beginning to end and look at all the variables that could come into play. I didn't mean that this really doesn't have to do with structure, but it just, I thought, was a good understanding of something, thinking of something big picture. Always think down the road, never think small. Okay, so now we're in a situation where, for whatever reason, we have to alter our table. Maybe something changed, and maybe our field size isn't big enough, or maybe we need to, heaven forbid, change the type of data that is stored in a field. Whatever it is, the command that we're going to use to actually alter the table is the alter table command. It's discussed in your text on pages 137 to 138, and it makes changes to a table structure, for example, adding fields, modifying data types or field sizes, removing fields. Let me give you some examples. Now, before I actually begin, I'm going to go ahead and reset my entire Premier database. So I reopened the SQL that created the database, inserted into the tables, etc. And I added first a line to drop the schema. So I'm going to go ahead and select that line and execute. That's going to drop that schema. Now you're still going to see it over here until you refresh, and you'll notice now my Premier schema is gone. And I added a line to what the author provided with create schema. And again, I execute it. That's not good. Of course, I paused for a moment when that error came up, just in case that happens to you. I did nothing but click the OK button, and I'm going to go ahead and create that schema. And it turned out it actually had created it, so I had to drop it again when I was figuring out what happened. But as you can see from the bottom of the screen, but whatever that bug error that came up, I just okayed it and everything worked fine. So at any rate, I've created my schema and executed, and again I refresh and you can see my Premier schema over here. And then this is all of the data that the author provided, other than, remember how we had to change that date format for our version, and I'm going to go ahead and execute that. I'm just not having a good day here, am I? Okay, I started my SQL Workbench over. Again, I'm going to drop the schema, and that executed fine. I'm going to go ahead and hit refresh. You can see that the Premier schema is gone. I'm going to create my schema. Down below I can see that executed fine. I'm going to refresh, and there's the schema. I am going to, I'm going to go ahead and double click on the schema, and I'm going to select all of the values from the author provided. Of course, this is a copy where I did change those dates to a date format that our version understood, and I went ahead and selected all of those lines, as you can see, and executed them, and it created and inserted into all of those tables accordingly. So that just reset everything back. just for purposes of this example. And you may periodically want to do that. Okay, so back to alter command. In this first command, I'm going to change the customer type. I'm going to add a column of customer type. So just so you can see, in our version, since we're using the workbench, I can go ahead and click on tables, refresh, and the customer table columns, and I can see the columns down here. You can clearly see there is no column called customer type. So I'm going to go ahead and select the alter table customer, add customer type as a character field, length of 1, and execute. Again, I do need to hit refresh, and I can see the customer type is now in my table design over here. The next one that they talk about is a modification to a table. I'm actually increasing the width of the field size of a field, the number of characters that a character field will store. It's always safe to go up. So I always tell people, start small, and if you need to, you can increase it down the road. If you start large and then you want to decide it's too big and you want to decrease it, you risk the possibility of losing some data. Now there's some tricks. You want to check your length. There should be a command you can run to find out what the longest number of characters that you use. In other words, if you had a field size of 50, but you check length and find out you're never using more than 30, then it's okay to come down to 30. But you don't ever want to just go down to 30, because if you had some that had 35 characters in it, you're going to lose that. And it's not something you're going to be able to go, whoops, undo. So at any rate, it's always safe to increase. So here the author wants to increase the table size, the field size of the customer name column to 40 characters. I can see down here on the left that it is currently 35 characters. So I've gone ahead and selected alter table customer, the name of the table, modify customer name, the name of the field, what I want it to be. I execute. And again, you will have to refresh in order to see that it has changed to 40. The next one that the author uses is dropping a column. This one is toward the end of this section on middle of page 138, it looks like. And so let's go ahead before we drop the column and let's take a look at what is in the part number column now. You can see there is a field called warehouse. It's a character field of 1, and we're going to go ahead and select the alter table part, so the name of the table, and then the command we're going to use is drop column warehouse. So when I execute, you can see it did run properly. I'm going to go ahead and refresh, and I can see that the warehouse column is now gone. Now remember, if I got rid of that column, then it's also going to get rid of any data that's in that column. And finally, on the top of page 138, another command that we have actually already briefly talked about is the drop table command. If you recall earlier, because I dropped my schema, that table is already gone. In a previous section, we had created a table called small customer, and that table, and I'm not going to take the time to recreate it, that table is gone because I dropped my schema at the beginning of the example without thinking ahead. But they now want me to remove the table small customer, and it's simply the command drop table and then the name of the table, and that would, if I had the ability to execute it, that would work. So that was on pages 137 and 138. Quickly skip through these here. Remember, when you are modifying table designs, always, before you do it, think about how this change affects other aspects of your database. Don't think small. Don't think of your department. Don't think of the people around you. You have to think big picture. How does it affect this other department in this other side of the company, or the people above me, the people below me, the people who are maybe even in another city? How does this database, this table, relate to other tables, to other applications? Do I dump this data into some other program? You really have to think big picture. And as a database administrator, you know all the different ways that your data is being used. always make a backup of the existing structure before you start to make changes, in case you need to revert. And of course, you should always have routine daily backups of your data and going on anyway. But even if though I have daily backups, if I'm going to modify a particular table today, the first thing I'm going to do is make a copy of that table so that if I screw this up or I change my mind or I realize it's not going to work, worst case scenario, I can go right back to what I had. Then beginning on page 138, the author talks just a little bit at the bottom of that page about making more complex tables. And as I already said, increasing, that says table size, I mean field size, but increasing the table size is okay. Increasing the field size is okay, but anytime you decide to reduce the field size, as I often pointed out, it is dangerous. The author also discusses that, and I agree, it is often better to use a create table command and create a new table designed the way you want it. Kind of depends on the situation, but then use a insert or a select into, what depends on what SQL you're using, but to actually take the data out of the old and put it in the new. And we've done that. We did some create table small customer and selected a set of data and inserted it into that table. Well, it'd be the same thing. I would create my new table and then I'd take the data out of the old table and insert it into the new table. I still have it as it was because it's the old table still there. I've got this new table. I can do some testing and things, and from there move forward, probably not deleting that old table design for quite a while, until I know for sure I've run through some type of reporting cycle, be it a month, a year, whatever. And then at some point in time, I'll come back and I'll go ahead and say, I don't need this anymore. It's just taking up space. I can go ahead and dump it. On pages 140 to 142, the author talks about system catalog, and the system catalog keeps information about the database and it's maintained automatically. So it's kind of like a set of tables that keep track of what the tables are in the database and what the columns are in the tables and how the columns, what the types of columns and the properties of the columns, and there's a number of them. The author really only draws your attention to two, and go ahead and take a look there, figure 426 and 427, which they're referring to as sys tables and sys columns. And in your text it does some discussion of how to select the column name and the column type from sys columns, etc. And kind of a theoretical thing. It's really the note on the top of page 142 that is relevant to the MySQL, where it talks about show tables and show column commands. So if we just take a look at those very quickly, the show tables command is simply going to show me what tables are in my Premier database. Notice that was simply show tables, and then I have show columns from, and I have to specify the name of a table, in this case the part table, and so now it's showing me the field name, the type, whether or not a null value is allowed, what type of key it is, etc. This really, since we're using the SQL Workbench product, is the same data that are very similar to the data that I'm seeing over here on the left, because I do see this. But if you weren't using the Workbench project, you would really more just have this window up here. So that's really all they talk about with the system catalog. The author then spends some time on stored procedures, and stored procedures are huge. We use them all the time in all kinds of databases. Basically, the database resides on the server, and then the users access it through clients. And so this can, obviously, there's going to be some lag time. So one thing that you can do to increase your overall performance is to use stored procedures. Another big reason to use stored procedures is, why should I be typing the same code or same set of commands again and again and again? Instead, if I store them in a stored procedure, I can then call on that stored procedure whenever I want those same commands. Now, before we actually write our first stored procedure, one of the things you have to understand that is in MySQL, the semicolon marks the end of a command. And you may have seen in my examples in the current versions, I rarely type a semicolon. I know in the homework many of you did, and that's cool. But it actually, it's a good habit to be, and I should do it. But it marks the end of a command, and that's known as a delimiter. In a stored procedure, we have to temporarily change the delimiter to something else. Maybe, two slashes, the author uses $2, something else. And then at the end of the stored procedure, we have to change it back to the semicolon. So what you're actually going to see is a command first to change the delimiter, and that's this delimiter. You can see here I'm changing it to $signs, and then a command down here at the end of it that's changing it back to a semicolon. And then between my delimiter signs is my actual stored procedure. In this example, I'm going to create a stored procedure that I'm going to name change credit. That stored procedure is going to request two things, need two pieces of data. It's going to need something called CNUM, which I have set as a character field up to 4 characters, and it's going to need something I'm calling CLimit, which is a decimal field with 8 characters and 2 decimal places. These 2 arguments are required every time I run the stored procedure. Then I use the begin command, and what is this stored procedure going to do? I'm updating the table customer. I'm setting the credit limit equal to CLimit, so to whatever the user typed in for the second variable, and customer number I'm calling CNUM, so whatever the user typed for the first variable. And then I end. I use that delimiter, and then that last command, remember, just sets the delimiter back. Now, to actually see this, we're going to do a little extra. First, I'm going to go and take a look at what I have now. So I'm selecting the credit limit from customer where the customer number is 356. When I do that, I can see very clearly that the credit limit is $7,500. Now I'm going to go ahead and create my stored procedure. So I've selected these lines. Remember, I'm setting my delimiter to something else. I create my procedure, I give it a name, I define the variables in that procedure, or the arguments in that procedure. I'm then going to start with begin. There's my procedure. I've got end, the delimiter I temporarily used, and then I set the delimiter back to a semicolon. When I execute that, I should really just see nothing but down here at the bottom it tells me that I'd created that stored procedure. Now, to actually use the stored procedure, I'm going to use the SQL function call. So I'm now calling a stored procedure called change credit. My 2 arguments are the 356, so that's my CNUM, which I've set here to be the customer number, and my credit limit, which I'm now changing to be 10,000. So when I execute that, again, all I see down here is that it ran and that 1 row is affected. But if I really want to understand what it did, I need to come back here to where I selected the credit limit from customer, where the customer is 356, and execute, so I can clearly see that what that stored procedure did for me is took that record from the customer table where the customer number was 356, and it changed it, the credit limit. So now anytime somebody wants to change a credit limit, and of course I would design this into a user interface, but what the SQL is doing is that end user can now type in simply a customer number, and then in the next box a credit limit, and push a button, and what it's going to do is run that stored procedure where it's going to change that credit limit for that customer. So if I have another one, I don't have to retype all of this and say update, set the credit limit to 10,000, the customer number to 356. Next one, make it 12,000 where the customer number is 357. And each time changing the code, each time I need to do it. I've now created the stored procedure, so anytime I want to do it, I simply call that stored procedure, change credit, and what my 2 variables are. If you truly are done with it, the author doesn't really discuss, but you can simply drop the procedure with a simple drop command, drop procedure, and then and then the name of the procedure. I wouldn't recommend scrolling in the middle of that. And where did it go? So there's my command I scrolled past, and I'm going to go ahead and execute it. And really all I can see down here is one row is returned. Of course, if I came back and tried to set the call, I'm going to get an error because it shouldn't be working anymore. And you can see when I ran it again that I do have an error message down here. So it's because I dropped the procedure. And finally, the author discusses triggers. And triggers are, in a way, they're not really similar to a stored procedure. I mean, they're similar in that I create them and I attach them to something. It's an action that's going to occur automatically. It's going to occur. It's a series of commands that I'm going to set to happen every time somebody inserts, every time somebody updates, or every time somebody deletes. They can happen before an insert, update, or delete, or they can happen after an insert, update, or delete. And I repeated it. We're going to have to go to the textbook now. And what you're going to see in the textbook is looking at page 143. I played and played and played with the MySQL to try to see if I could come up with an example to actually show you how this would work in MySQL, but I couldn't come up with anything without writing some quite a bit more elaborate stuff. It just was not working for me. So I don't know if in the version we have we just don't have the privileges to set triggers. I did do a lot of reading on it, and we do have to have some privileges set. Maybe in the version we have that's not allowed. I just got to the point of this is such a small unit, let's just talk about it and move forward. So a trigger would, for example, in their first one, they're on page 143, they're talking about again, they set that delimiter and they create a trigger called add order line. After every insert on order line, they are going to execute this trigger. The fourth line of the code is the important part. That indicates what SQL command is going to occur for each row that's added. Similar to a stored procedure, it's enclosed between the words begin and end. In this case, the SQL command is an update command. It uses the new qualifier referring to the row that's added to the order line table. So you can think of it as maybe every time a user adds a record to one table, I want maybe something to a particular query to run, maybe another, I use them more in my interface that I want, maybe a particular form to open, or I want another command to run, but I want it to happen every time right before they insert or right after they insert, maybe right before they delete a record or right after they delete a record. So what's important to understand about triggers is that I can attach them to the insert, the update, or the delete. Every time they insert or add a record, every time they update or change a record, every time they delete a record. I can do it right before or right after. It's a series of SQL commands that I want to be executed at a particular trigger. That's really all you need to know for that part of the unit. The rest of the chapter is devoted to access macros. The author spends some time there on macros, and I don't know if you've taken an access class or not. When I'm teaching access, we'll spend a little bit of time on macros and then turn right around and say, okay, yeah, that was a nice exercise. Now let's really get into some Visual Basic, because you would really spend more time writing that. But in access, it's the macros or the VB code that I would be using to execute my triggers. So I think that's why the author is spending time on it. That concludes the things that are important in Chapter 4.